Hello everyone, my name is Manasa. I'm working as an assistant professor in Mallareddy Engineering College. Today I'm going to discuss about some topics in operating systems. So let's start the class. So firstly, definition of computer. So we know that the computer is a combination of hardware and software resources. So here, what are the resources? Resources are nothing but input devices and output devices. These are comes under the hardware resources and the software resources. The software resources are with those softwares, the computer will not work. So the combination of hardware and software resources, uh, these both together and provides the various functionalities to the user. So instruction execution. This topic, instruction execution, explains the how the instructions will be executed in the computer. So how the CPU will take the each and every instruction. Here CPU is nothing but processor. So CPU will plays an important role in execute the each and every instruction. So the number of executions, the group of executions, or the collection of instructions. Sorry, the collection of instructions are called as the instruction set of architecture. That is ISA. So the program to be run consists of the instructions stored in memory. So CPU will execute the instructions to finish the each and every task which are provided in the program. So the CPU is primarily responsible for the execution of the instructions, and those instructions are executed in CPU registers. So this is the instruction cycle. So to execute the each and every instructions, those instructions will follow these steps. So this cycle will start from the fetch instruction. Firstly, CPU will fetch the instructions from the memory. So next, decode the instruction. Decoding instruction means the computer will understand only binary language. User will give the instructions to the computer in the English language, in his own language, by using some programming languages. So computer has to decode those instructions. And next is ALU, arithmetical logical operations. Here all the arithmetical and logical operations will be performed. This is the third step. And the fourth step is access memory. Here, accessing memory means the memory will be accessed. In two ways, the memory will be accessed: to store the data into the memory, or to use the data which is already stored into the memory. That is accessing the memory. Next is update register file. So, register file has to be updated to use the data and update the program counter. These are the 1, 2, 3, 4, 5. These are the 5 steps are placed in the instruction cycle. So here some definitions are there in instruction cycle for each and every step. Fetch instruction. What is fetch instruction? The fetching instructions from the main memory begins the execution cycle. The current program counter will acquire the instruction placed in the instruction register. Next step is decode instruction. During this cycle, the decoder interrupts the encoded instruction stored into the instruction register. Third step is perform ALU operations. So, two operands in the instruction will be operated on the specific operator in the instructions in the ALU. For example, if the instruction were added two numbers, the addition of occur here. The outcome of the process is output by the arithmetical logical unit, which takes the two values and outputs 1. And next is accessing memory. There are only too many access instructions: load and store. A value from the memory is copied to a register by load, and a register value is copied to memory by store. And fifth step is update the register file. The arithmetical logical unit output or result is written back to the register file in the phase of update the register file. So sixth step is update the program counter. At the completion of the current instructions execution, we must update the program counter to the address of the next instructions so that we may return step 1 and have the CPU acquire the next instructions. These are the execution of instruction cycle. So these are the 5 steps, 6 steps, which the each and every instruction has to follow. So these are the definitions of all those 6 steps. Next is memory hierarchy. Memory hierarchy is designed to use the memory properly. The main problem of memory devices are very expensive. So to use those expensive data, expensive devices, we have to store the data into the memory according to the size of the data. For that, we need to follow the memory hierarchy. So there are 5 this memory hierarchy is divided into the memory is divided into the 5 hierarchies. First one is registers, cache memory, main memory, magnetic disk, magnetic tapes. So here first 3 parts, registers, cache memory, main memory, these are called as the volatile. And fourth one, magnetic disks and magnetic tapes are called as the non-volatile. First 3 are the temporary memory and second 2 are the permanent memories. This is the diagram of the memory hierarchy. The memory hierarchy, in the hierarchy diagram, it is designed in the triangle shape according to the size of the memories. So first register memory. Registers are the very low size. So that's why it takes the first place. And next is cache memory. According to compared to the register memory, cache memory is bigger. So it is placed second memory. And third one is main memory. And fourth one is magnetic disks. And lastly, magnetic tapes. And the characteristics of memory hierarchy. Here, the performance, ability, access time. Characteristics means the memory is divided into the five hierarchies based on the performance of the memory and ability of the memory and accessing time of the memory. By considering all these 3 things, the memory is divided as these 5 hierarchies. So let's discuss the all what are the characteristics. So performance. The designing of a computer system was done without memory hierarchy, and the speed gap among the main memory as well as the CPU register enhances because of the huge disparity in the access time. So ability. Next thing is ability. The ability of the memory hierarchy is the total amount of data the memory can store. Because whenever we shift from top to bottom inside the memory hierarchy, then the capacity will increase. And next is last one is accessing time. So accessing time is the access time in the memory hierarchy is the interval of the time among the data availability as well as a request to read or write. So memory hierarchy designs. Let's discuss the each and every memory hierarchy parts. The first one is registers. Registers are the very cheapest and very quickly used device to store and transfer the data and the instructions that are being used immediately by the CPU. So the registers used by the CPU are often termed as the processor registers. The processor register may hold the instructions, a storage address or any data. Next is cache memory. The cache memory can also be found in the processor. It is also called as the integrated circuit. The cache holds the chunk hold of data which are frequently used from the main memory. So magnetic disks. The third part is magnetic disk. The magnetic disk is the type of secondary memory that is flat disk covered with a magnetic coated to hold information. It is used to store various programs and files. Magnetic disks are less expensive than RAM and can store large amounts of data, but the data access rate is slower than main memory because of secondary memory. Data can be modified or can be deleted easily in the magnetic disk memory. Last one is magnetic tapes. In magnetic tape, only one side of the ribbon is used for the storing data. It is sequential memory, which contains thin plastic ribbon to store data and coated by the magnetic oxide. Data read or write speed is slower because of sequential access. It is highly reliable, which requires magnetic tape drive, writing and reading data. Let's discuss about the introduction of operating system. So an operating system provides an interaction between the user and computer hardware. That means operating system will act as the driver in the computer. So operating system will operate all the systems. Means it will operate. It will take all the control of the all the input devices, hardware parts, and software devices. So we can also that's why we are saying that it is the interaction between the user and the computer hardware. A user is a person sitting with the computer terminal concerned about the application rather than the architecture of the computer. The user never interacts with the hardware directly. To get the services of the hardware, he has to request through the operating system. So this is the diagram of the definition of operating system. The operating system is the interface between the user and hardware devices. Here, these are the some functionalities of operating system: resource management, process management, storage management, memory management, security. So here in the previous slides, I have explained that what are the resources. So resources are nothing but input devices, output devices. These are all called as the resources. So here, operating system will maintain all the resources. These resources called as the resource management. Process management. Process management means CPU scheduling. How the CPU will executing the each and every instruction. Third one is storage management. How the all files are maintained. This system is called as the storage management. Memory management. In this memory management, RAM will be maintained. And last one is security. How the security provided to the computer will be explained in this part. So the functions of the operating systems are resource management, process management, storage management, memory management, and security management. Thank you everyone. If you have any doubts, you can ask me.